Section R.2, Part 2. Exponents. All right, so if we have a positive integer exponent, then if a is a real number and n is a positive integer, then the symbol a to the nth power represents the product of n factors of. So a to the nth power means multiply a by n times. Okay, a is called the base of the expression, and then n is the exponent or the power. Okay, so let's say we have 5 to the third power. So this means 5 times itself 3 times, so 5 times 5 times 5, and we come up with 125. 5 squared, 5 times 5, or 25, and then 5 to the first power is 5. Okay, so what if now we want to figure out what 5 to the 0 power is, 5 to the negative first, 5 to the negative second, etc. Okay, so the rule we have above for positive integer exponents applies to 5 to the third, 5 squared, and 5 to the first. Okay, but we need a different rule for these other guys. If we want to go down our list, notice that to go from 125 down to 25, we can divide by 5, which makes sense because we're multiplying by 1 less 5. Okay, to go from 25 down to 5, we've also divided by 5. Okay, so if we keep up that pattern, we'll divide by 5 again. So 5 divided by 5 is 1. 1 divided by 5 is going to give us 1/5. Now for 5 to the negative second power, we start with 1/5 and we divide this by 5. We can think of 5 as 5 over 1. And remember, when you divide by fractions, multiplied by the reciprocal of the second. So this 5 over 1 will become 1/5. And now we're multiplying our two fractions. So 5 to the negative second power is equivalent to 1 over 5 squared, or 1/25. Okay, again, following that same pattern, 5 to the negative third power is going to be 1 over 5 cubed, or 1 over 125. Okay, we have 0 as an exponent. On the last slide, we determined that a number to the 0 power equals 1. This is true for any real number except for 0. 0 raised to the 0 power is undefined. However, we won't be discussing that in this class. Okay, exponents. So if a is not 0 and n is a positive integer, then a to the negative nth power can be written as 1 over a to the n. So for example, if we have a to the negative fourth power, we could write this as 1 divided by a to the fourth. If you start with a negative exponent that's already in the denominator, so let's say we have 1 over a to the negative sixth, it's already in the denominator, we can simply move it to the numerator, and then it becomes positive, so a to the sixth power now, over 1, but we wouldn't need to write divided by 1. Okay, so anytime you have a negative exponent, I just say move it, so if it's up top, move it to the denominator. If it's already in the denominator, move it up to the numerator. Okay, next I want to look at a few examples, and then we're going to determine what it is. Okay, so we have x cubed times x to the fourth. So we're going to write out the x's in the expression. So x to the third power is x times x times x. We're multiplying this by x to the fourth, which is x times x times x times x. Simplify, and we have x to the seventh power. Okay, so what's the shortcut? Because we certainly don't want to have to write out all these x's all the time. So we started with x cubed, we multiplied it by x to the fourth, and we came up with x to the seventh. So the rule is that when we're multiplying and we have the same base, we add our exponents together. Okay, next, let's say we have raised to the fourth power. So we'll do it again. We're going to write this out. So x cubed to the fourth power means multiply x cubed by itself 4 times. If we're writing out all the exponents, then all of these are x, right? X times x times x, and then one more time, x times x times x. Okay, so simplify. We have a total of 12 x's if you count them all. Okay, so again, the shortcut, we started with x cubed and raised it to the 4th power and came up with x to the 12th. So the rule is that if you have a power raised to a power, multiply the exponents together. Okay, so we're going to review the law. A to the 0 power is equal to 1. Nth power becomes 1 over a to the nth. Multiplying with the same base, add the exponents, power raised to a power, multiply the exponents together. We have a few more rules. These two I would say go together. So when you're multiplying and you have the same base, we add the exponents. So when we're dividing and we have the same base, we subtract the exponents. If a times b is being raised to the mth power, we apply that exponent to both, the a and the b. Similarly, if a divided by b is raised to the nth power, both the a in the numerator and the b in the denominator are raised to that nth power. So we apply the exponent to both. Okay, we can't divide by 0, so that's why we have a is not equal to 0 and b not equal to 0 in this case. Things I want to note about this property here. When we divide and we have the same base, we can subtract the exponents. There's a shortcut, that way we never end up with negative exponents. So look to see where you have more x's. X to the 7th divided by x to the 4th. There's more x's up in the denominator, so that's where my in the numerator. So that's where my x's end up. And 7 minus 4 is 3. So our answer there is x cubed. For the second problem, I have more x's in the denominator, so I'm going to end up with 1 divided by x to a certain power. Okay, so this time we subtract. Start with the 12 though, so 12 minus 5, or 7, so 1 divided by x to the 7th is our answer there. Okay, simplify each expression, express answers with only exponents, and we're going to assume that any variables are non-zero. Okay, hopefully this first one is straightforward. We're multiplying and we have the same base. So if you remember, we add our exponents together. The second guy, we are dividing and we have the same base. So I'm going to subtract the exponents. I know ahead of time that the x's are going to end up in the denominator. So I'll subtract 6 from 15. So 1 over x to the 9th is my answer. 4 raised to the negative 3rd power. So remember, negative exponents are brought to the denominator, so I have 1 over 4 cubed, which is 1/64. Okay, a few more that we'll do together. Now we have 4x to the 5th y cubed all raised to the 2nd power. So I'm going to apply this exponent to all three. So 4 squared is 16. X to the 5th squared, so remember power raised to a power, so we multiply our exponents together. Same thing for the y, so we'll get y to the 6th power. Okay, for this next one, I will do this in 2 steps. So all three of these guys, first of all, get raised to the 3rd power. Okay, so 2 to the 3rd power is 8. X to the negative 1st raised to the 3rd power. Multiply our exponents together, so I have x raised to the negative 3rd power. In the denominator, same thing, power raised to a power, so I multiply my exponents together. Okay, we were asked to express answers with only positive exponents. The 8 stays where it is because it has a positive exponent of 1 with it. X cubed comes to the denominator. Y to the 9th stays in the denominator because it had a positive exponent. Okay, for this last one, I'll do something similar. First, I'll just apply this -2 exponent to everything. So I have 2 to the negative 2nd, x to the 6th, right? Because a power raised to a power, I multiply my exponents together. Y is raised to the negative 2nd power. In the denominator, 3 is raised to the negative 2nd power. And then this x is now being squared, since I had -1 times -2. Okay. In my next step, I'm just going to move anything that has a negative exponent. So 2 squared is going to come to the denominator. 3 squared comes to the numerator, x to the 6th stays where it is, x squared stays in the denominator, and then y to the negative second comes down as y squared. Okay, one more step. So 3 squared, I'll write that as 9 in the denominator. 2 squared is 4. Okay, so I have x to the 6th divided by x squared. There are more x's in the numerator, so I'll write my x beside the 9 in the numerator. And since 6 minus 2 is 4, I know I have x to the 4th power in the numerator, and then y squared is in the denominator. Okay, example 5, you're going to complete these on your own and turn them in through Canvas. So 3x squared y to the 5th is being raised to the 3rd power, and for part B, 5x to the negative 4th, y, z to the negative 2nd is all being raised to the negative 2nd power. Okay, the last example deals with PEMDAS, or the order of operations. We want to know how the order of operations is going to affect these answers, especially parts A and B. Okay, both A and B are read negative 3x to the 4th power. Okay, the difference is just by saying that you don't know if there's parentheses or not, right? So part A has no parentheses, part B has parentheses around the negative 3. Okay, and that makes a difference because a negative really means multiplied by negative 1. Okay, and multiplying is one of the third steps, right? Multiply and divide go together, but it's the third step in PEMDAS. So parentheses applies for part B. We would do what's inside the parentheses first, meaning multiply that negative 1 times 3. We just think of it as the number negative 3. Okay, but we do that first and then apply the exponent. So for part B, the base of the expression is negative 3. So we multiply negative 3 by itself 4 times and we come up with positive 81. In part A, we apply exponents before we do this multiplication by the negative. So part A is really the opposite, or negative 3 to the 4th power. So 3 times 3 times 3 times 3. So inside the parentheses, I have 81, but then I take its opposite. So the final answer for part A is negative 81. Okay, so it makes a difference whether there are parentheses or not. Okay, part C, no parentheses. So this negative that's out front is done after we apply the exponent. Okay, so this is the opposite of 3 to the negative 4th power. Sorry, so I'm going to write that as 1 over 3 to the 4th power since I had that negative exponent. So we get negative 1 over 81. Okay, so you have a couple examples to do from example 5 that you'll do and turn in through Canvas. Okay, if you have any questions, let me know. Good luck.